Hi class, today we're going to do graphing rational functions in section 8.3. We're going to do the general form. So what I'd like you to do is pause the video and go ahead and do the warm-up and then come back when you're ready to check. Okay, I hope you paused it and got your work so you can now check it. So when we look for our asymptotes, we're looking to see where things level off in our graph, and we can see that the arrows are kind of leveling off here. And on the other side, we have this branch that is leveling off here. So that tells us that there's this horizontal asymptote at y equals 1. To look for our vertical asymptotes, we can see that this branch is leveling off as it approaches infinity here. And then we have this vertical asymptote at x equals -1. You can also see this branch down here approaching that asymptote. Over on the right-hand side at x equals 1, we have this branch approaching the vertical asymptote, and then in the upper right-hand corner we have this branch approaching this asymptote. So your function is always going to approach your asymptote. The graph is going to get closer and closer and closer to the asymptote. It's never going to cross the asymptote, and it's not going to steer back away. So there we found that our two vertical asymptotes are at x equals -1 and 1. Algebraically, we can find that by taking our denominator and factoring your denominator to look for where your function is undefined. Because wherever this is divided by 0 or undefined is where we're going to have a vertical asymptote. And these are the two spots, these vertical lines, where the graph is not defined. So the domain is going to be all real numbers except for when x equals + or -1, because that's where we have our vertical asymptotes. And we have the branches of the graph everywhere except for where the vertical asymptotes are. Similarly, when we're looking for the range, we're going to look for this horizontal asymptote. And I see that it's up here above the horizontal asymptote of 1, and I see that it's down here as well. So I know it's not here at y equals 1, but additionally, I don't see anything in this space here. So it's not 1 because it levels off at 1, so it's going to be greater than 1, but we also have it down here, and this value is y equals -1, and it's going to be below -1. So if you wrote that it was all real numbers except y equals 1, had this horizontal asymptote correct, but you really want to look at where the y values are. So the y values are at y is greater than 1, and then also the y values are less than -1. So let's go ahead and fix that in our range. So here I updated my range, so it includes where you have the asymptote. So you have your y's are bigger than 1, not including y equals 1 because it's going to get closer and closer to. So it's y is bigger than 1 for these upper branches, and then down on the lower branches it goes down to -infinity and goes up to -1, and it includes this y value of -1, and includes all of these y values down below. So the lower branches y is less or equal to -1. So let's look at number 2. Again, I set the denominator equal to 0 and factored it to get my two vertical asymptotes, and you can see your branches approaching the vertical asymptotes, upper and lower. So I have x equals -1 and x equals 1. Then I have my horizontal asymptote at y equals 0. You can see the branches lowering down. And again, the domain is all real numbers except for where those two vertical asymptotes are. And the range, again, if you looked at it and said it was all of those, that's part of it, but you have this other section here that is missing. So let's go ahead and update our range. So here I updated my range so that it's greater than 0. So here's y equals 0, and it's all the numbers bigger than that. And then it's down here. And we can see it has this maximum value right here, but it's not clear what value it is. So in order for me to get -1.8, I graphed this on the calculator and did a calc max to find that value for the range. And I know that its y is less than or equal to -1.8. Okay, let's go on to the lesson. So on this side, we're talking about rational functions where you have a polynomial divided by a polynomial. Take a moment, pause the video, and read through the different types of discontinuity points. Welcome back. So for a point of discontinuity, it's whenever you take the denominator and set it equal to 0, and that's going to be your points of discontinuity. Your points of discontinuity is when the denominator equals 0 and your function is undefined. If you can remove it by canceling out one of your factors, if you set your denominator equal to 0 and you get some number x equals -2. If it gets removed by canceling it out, it ends up being a hole in the graph, and you can plug -2 into the leftover part of your function that was not taken away. If you plug -2 + 3, you get 1, and so you have a hole at the point -2, 1 in your branch. Then you have the non-removable discontinuity points, and that's where you end up with your vertical asymptote. So you set your denominator equal to 0 at x equals 2, there's a vertical asymptote. Okay, let's move on. Okay, so here are some steps we're going to use when we're going to graph. So what we're going to do is we're going to take our denominator p of x and we're going to look for the x-intercepts. So we're going to set the numerator equal to 0 to find our x-intercepts. And then the graph has a vertical asymptote when your denominator equals 0. So we're going to set your denominator equal to 0 and we're going to solve. And then we're going to look at the horizontal asymptotes. To determine the horizontal asymptotes, we're going to look at this table. We're going to look at the degree of the numerator and the degree of the denominator and compare them. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is your horizontal asymptote. If the degree of the top and the bottom are the same, then you're going to look at the line y equals the leading coefficient of the top and divide that by the leading coefficient of the bottom, and that's going to be your horizontal asymptote. And if the numerator's degree is bigger than the denominator's degree, then you're going to have no horizontal asymptote, and what you're going to have is some sort of slant asymptote, and it's going to model this behavior for your slant asymptote. So it's the coefficients, and then you subtract your degrees. And we'll see this in action. So let's go on to the next slide. So on this next one, it's this 5-step process for graphing these rational functions. So we're going to find x-intercepts, if any, by setting the numerator equals 0. We're going to find the vertical asymptotes by setting the denominator equals 0. We're going to look for horizontal asymptotes by using the chart. We're going to look for the y-intercept by plugging in x equals 0, if there are any, and then we're going to plot points beyond and between the asymptotes, and we need between 6 and 10 points per graph. So we're going to have some on one branch, some on the other, and sometimes you might just have one branch and you'll have to have multiple until you can see what the graph is going to look like. So let's go ahead and move on to example number 1. So here we're going to find the x-intercepts. So the x-intercepts are going to occur when the function equals 0. So for this one we set y equals 0, and then you set your numerator, x equals 0. So you have an x-intercept at 0, which is the point 0, 0. So I know it goes to the origin. So that's going to be the same as the y-intercept. You can find the y-intercept by plugging in x equals 0, and you end up that y equals 0 over 1, which is 0, which again confirms that it goes to the origin at 0, 0. To look at the horizontal asymptote, you look at the degree of the numerator, which is 1, and the degree of the denominator, which is 2. In this case, since 1, the numerator is less than 2, the denominator, we have the m is less than n case, and when m is less than n, you know that y equals 0 is your horizontal asymptote. So I'm going to go ahead and draw in my horizontal asymptote. Make sure you draw a dashed line for your horizontal asymptote. Then we're going to go ahead and graph our vertical asymptote. So our vertical asymptote, you take your denominator and set it equal to 0. So I get x squared plus 1 equals 0, or x squared equals negative 1, and this is not a real number. You get plus or minus I. So that means that there are no vertical asymptotes. So we don't have any vertical asymptotes, so we're just going to need to plug in numbers. So you're just going to make a table of values that are going to fit here. So for example, you could choose negative 3, negative 2, negative 1, 1, 2, 3. Go ahead and plug these numbers into your function to find the corresponding y values. Pause the video and do that. Okay, I went ahead and wrote down all those values. So now what we're going to do is we're going to graph the x comma y pair. So I'm going to graph negative 3 comma minus 0.3. So let's go ahead and do that. Okay, so I went ahead and plotted these points. Since my y's were only going up to 0.5 and minus 0.5, I made each of these a 0.1 value. On the x's, they went by 1, so I went by 1s. So I have my dots plotted. I know that my graph is going to approach my asymptote. So starting on the left, I'm going to have a smooth curve that approaches this asymptote. It's going to go through all of these points, and then it's going to have this turn where it ends up going up here and then back up there. So I'm going to do a curve, and then it's going to come back down, and I know it's going to be smoothing out. Now if you're not really sure what's going to happen here, then that's where you can plot more points. Since there are no vertical asymptotes, I know that my domain is going to be all real numbers. Okay, let's move on to the next example. Okay, so for this one, I have a 1 for my leading coefficient here and here. So to find my x-intercepts, I'm going to set my numerator equal to 0, and I get 0 equals x squared, or x equals 0. So again, I have it going through the origin 0, 0. To find the vertical asymptotes, you set your denominator equal to 0. I have x squared minus 1 equals 0, x squared equals 1, and so you get x equals plus or minus 1. So I have two vertical asymptotes, one at x equals 1 and one at x equals -1. So I can go ahead and draw those dashed lines in for my vertical asymptotes at x equals 1 and -1. You take your square root, don't forget your plus and your minus. Your horizontal asymptote, you look at the degree at the top and the degree at the bottom. Since your n equals m because your 2 equals 2, your horizontal asymptote is the line y equals your leading coefficient of this divided by your leading coefficient of that, which is y equals 1. So I'm going to go ahead and draw in my horizontal asymptote at y equals 1. Again, we're using the table to find the horizontal asymptote. The y-intercept, you plug in x equals 0. When you plug in x equals 0, you have 0 over -1, which is 0, which again gives you 0, 0, which we already knew that was the y-intercept. Okay, so then now we need to do our beyond and between points. So beyond. So here's one asymptote, vertical asymptote. You're going to go beyond this. So we need some points out there. So for example, one point beyond here would be -5. Just to make sure we have enough, I'm going to do -3. Between your vertical asymptotes, we're going to need a couple points between our vertical asymptotes. So between our vertical asymptotes might be like -1/2 and +1/2. You can pick anything. And then we can go ahead and pick numbers beyond our asymptote over here. So I could do numbers like 2 and 3. And then I can see what happens. Okay, so let's go ahead and plug these values in and see what we got. Okay, so I filled out my table, and I'm going to go ahead and plot my points. I'm going to go by ones on the x-axis and on my y-axis. You can also go by ones. If it's easier, you can make every other box being 1 to give you a little bit more accuracy. So I'm going to make every other box here 1. So they're 1, 1, 1. Okay, so why don't you go ahead and plot your points, and then we'll talk about how we connect. Okay, I plotted my points. I have -5, 1.04, -3, 1.1. And I know that my function is going to approach my asymptotes on both of them, and it's not going to cross my asymptote. So I know I'm going to have a branch up here. So I'm going to start on the left-hand side, and I have my arrow close to my asymptote, and I'm going to draw a smooth curve, and it's going to approach my asymptote. Okay, so these are my 2 points that I need to make sure I go through, otherwise it just should look curvy, and it shouldn't go up and away from your asymptote. In the middle branch, I have this point here, and I know it's going to go through these 2 points, so it's actually going to look like a parabola on the bottom, where it's going to get closer to your asymptotes down below. And it's really cramped in there, so you do it the best that you can. And clearly we can't put all of the values in there, but I can see that my dots are very clear, and those dots are accounted for in my table. In the right-hand branch, I have these 2 points, and again, I'm going to start at an asymptote, and I'm going to draw a curvy branch that goes through those dots that connects both dots and approaches the other asymptote. So the domain is going to be all real numbers, except for where you have your vertical asymptotes at 1 and -1. You can see it spanning everywhere else. So I know that my domain is x cannot equal ±1. The range, I don't have anything here as a maximum, so my range is that y is bigger than 1, but not equal to 1, and y equals 0 and everything down below, and its y is less than or equal to 0 because it's everything down there. But there isn't any y values there. So to find the range, you really need to graph it to see what it is. So let's go on to the next example. Okay, so for this one, what I'd like you to do is pause the video and try to fill it out as much as you can, and then I'll walk you through it. Okay, so here I found everything, so go ahead and check. I realized that I needed a lot more values to determine what my graph is going to be like, so look at the values that I chose. So next step is to plot these points. So go ahead and pause the video and do that. Okay, here, so I just went crazy plotting a bunch of different points. So you remember that it approaches asymptotes. We can see here that it's below the asymptote, and then it's going to go above the asymptote. The idea that it's going to level off and approach the asymptotes out at the ends. And functions can actually cross the asymptotes near here, it just has to approach asymptotes at the end. It is never going to cross a vertical asymptote, but it could cross a horizontal or a slant asymptote. So here it looks kind of funny, and then it's going to continue approaching the asymptote there. Then we're going to have another branch over here, and it's going to approach this asymptote over here on this side, and you would just plot as many points as you need till you have a clear idea of what it's going to go. Again, it's not going to cross that asymptote. Okay, so here I can see it's all out here and it's all out here. So the domain is all real numbers